few things to note about the projects. The first thing is, if you look at the projects down here, I'm going to talk about the next binary game today, and then you're going to need a Windows machine pretty soon. And if you don't have the ability to run a local virtual machine, you should use a cloud machine. Now, there are instructions here to make a cloud machine on Azure, but today I got my Google Cloud credits. So if you go into the canvas, you will find an announcement up here for your Google Cloud coupons. You can get a $50 Google Cloud coupon to give you $50 of free cloud service at Google. So that's an alternative. You can use the Google Cloud instead. And I will add instructions to the projects for making a Google Cloud machine. Right now, I think I only have the Azure instructions here, but I have the Google instructions too. I've used them in other classes. And so that's another option if you want to set up a cloud machine. Of course, if you can run a local virtual machine, that's fine. Or if you even want to use a real physical install of Windows, it's okay for what we're doing in this class, although it's not a good practice for real investigations, but none of the stuff we're using here is too dangerous. Anyway, you should be aware of that. If I have students who have used up all their free credits at the free cloud services, and therefore this is the solution. Get your Google Cloud $50 coupon, and that way you'll have some service you can use to get some virtual machines. The most important thing is to turn off the Windows machines when you're not using them, because Windows machines chew through your money fast. Linux machines are only like $1 a day. Windows machines are like $5 or $10 a day. So if you leave it on for a week or two, all your money will be gone. Anyway, that's the. Now let's talk about binary games. So last time we did nibbles, and so this time let's try bytes. I got a couple of these bytes. All right, this thing is hosing me again. There. All right. All right. So I guess this will do. All right. So we talked about this before. Normal numbers are base 10. So if you write 147, that's 1 times 100 and 4 times 10 plus 7 times 1. So you have hundreds place, tens place, and the ones place. In base 2, all you have is 0 and 1. So you'll have the ones place, the twos place, and the fours place. And for nibbles, you'll have 4 bits. So you can count up to 15 with nibbles. 1, 1, 1, 1 is 15 because it's 8 plus 4 plus 2 plus 1. 10, 10 is 10 because it's 8, no 4s, a 2, and no 1s. You start from the right. This digit is the number of 1s. The next one is the number of 2s. The next one is the number of 4s. And the next one is the number of 8s. So that's how you can figure out a nibble. And there it is, the 1s, 2s, 4s, and 8s. So this number is 9, 1, 8, plus 1, and nothing else. And so for a byte, you just extend this to 8 bits. So you have 1, 2s, 4s, 8s, and then you have 16s, 32s, 64s, and 128s. Now this is the most difficult way to convert binary to decimal, but it's the easiest to understand if you're new to it. And it does mean you now have to add these big numbers. So this thing, 1001, 1001, is 128 plus 16 plus 8 plus 1. So that'll add up to 153, and you pretty much have to write this on a scrap of paper or something if you want to get this right. It's pretty cumbersome, but that's a way to do it. And so there are some games to play here, like here. Let me shrink this down a bit. And what I did was I put a space in the middle of the byte, just to make it easier to see the left 4 bits and the right 4 bits. That's not how they usually write it, but it makes it a whole lot easier to read. So what is this in decimal? And got any comments? Okay, I've got it. Don't see any answers coming up. Oh, there I see some answers coming up. Anybody here got an answer? 37, right, because this is 1, 2, 4, 8, 16, 32. That's 32, and this is 5. So it's 37. Good? How about this one? Ah, I got it. And somebody got it ahead of me. Good. Anybody in the room got it? This one could be annoying. There's always shortcuts. What I do is, if it's all ones, I know that's 255. And this, yeah, 191. This is 255 minus 64. If they're all ones, it'd be 255, and this is the 64 that's not there, so I just did 255 minus 64 to get to 191. But you could also do 128 plus 32 plus 16 plus 8, 4, 2, and 1. 191. All right, just one more. How about this one? That one I know right away. 11, right. Nibbles I know. 10, 10 is 10. This is one more. That's 11. All right. So anyway, there's two games you can play here. But this one you convert binary to decimal. And the next one, I think you convert decimal to binary. Yeah, so take 200 in binary. Which one of these is 200? So it's going to be, okay, I got it. Nobody's coming up with this one in a hurry. But if you've taken Cisco, you get pretty good at these because you learn a bunch of them by heart. Aha. Someone has a question. I see someone has an answer there, which is the right answer. Yes. Strawberry or something got the right answer. Yep. Anybody in the room got it? It's not this one.
No.
This one.
Yeah.
Yeah, it is this one. Now, because 128 and 64 is 192, and then you need 8 more. So it's this one. Good. All right. How about this one? 211. Boy, that's annoying. Let's see. Okay. Okay, I've got it. Same kind of logic works. Yep, it's the first one, because it's 192, and then you need 8 and 11, that's 19 more, so that's 16 plus 3. So this is 192, that's 16, and that's 3. That's how I did it, so it is this one. All right, we'll just do one more of these. 109. Okay, I got it. And I see some answers there, but I think they're, no, those are a different one. Anybody got it? I don't see the right answer coming in from the online people.
The second one.
It's the second one. 96, 64 and 32, this is 96, so I need another 13 after that. And this is 13, 12, 13, because I know my nibbles. So that's how I did it. All right, so that one. All right, so anyway, after you get 10 in a row right, you find a flag, and that's how it goes. All right, that's all I wanted to show you this time. Next time we'll do hex, but not this time. So I'm going to stop that.